Hello and welcome to Applied Electronics Practical. Myself Sanjit Kumar Singh, lecturer at Electronics and Telecommunication at Praveen Patil Polytechnic, Bhayandar. So today we'll do the ninth practical. Practical is of a single tuned amplifier. So the competency or practical skill required is to be developed is to use discrete electronic devices and voltage regulators. Then relevant course outcome expected is to use transistor as low power amplifier, and practical outcome expected is to build or test performance of single tuned amplifier using transistor. Here we have used BC107. So this is the transistor. These are the similar type of transistors, NPN type of transistors that can be used. This is the practical circuit to be implemented. So the materials required, the resources required for performing these practicals are here. The CRO for observing the waveform, input-output waveforms, regulated power supply for supplying the VCC supply of 10 volt or 12 volt. Transistor we have used BC107. Resistors are used as per given and capacitors are used as per given. Inductor we have used 100 micro Henry. This circuit is mounted, components are taken and mounted here. So this is the transistor. This is the transistor BC107 with the forward current gain of 40. This is 1 microfarad. This is 10 microfarad as coupling capacitor for output, and bypass capacitor of 10 microfarad as input as the bypass capacitor, and 1 microfarad capacitor as the input coupling capacitor. Then this is 68 kilo ohm resistor, 12 kilo ohm resistor forming a potential divider method of biasing. Then this is the tank circuit formed of inductor and capacitor. This is the inductor of value 100 micro Henry, and the capacitor of fixed type of capacitor we have used 47 nanofarad. So initially we are setting the VCC at 10 volt, and here the frequency we have fed is 50 kilohertz. So and input voltage is from function generator we are taking 20 millivolt, 1 division into 20 millivolt peak to peak. Output we are getting on the second channel of the CRO as near about here we are getting 100 millivolt. So we need to change the frequency of the input signal. So from 50 we can increase, because below that the output voltage we can see decreases. Below this value output voltage decreases, and above this the voltage gain is still obtained. So for 55, then 60, see the increase in the voltage of the second channel. Output voltage is obtained across the coupling capacitor. This is the coupling capacitor, and from here we are taking the output and observing on the CRO. This is the first channel for giving the input from the function generator. So as we increase the supply frequency, we can see the voltage has increased, so we need to shift from 50 millivolt per division to 100 millivolt or 0.1 volt setting. So at 72 we can see it is near about 350 millivolt, and as we increase further, as we increase the frequency further, we can see the increase in the output, and maximum output we have obtained at near about 74 kilo ohm. So near about 74-75 kilo ohm we are getting practically the resonant frequency, and if we increase the frequency beyond that, say for instance at 80, the voltage reduces, 85 voltage reduced. So as we go on in 90, 98, for 100 kilohertz the voltage has reduced to 150 millivolt order, and beyond that, as we increase the frequency to 153 kilohertz, the voltage, output voltage has decreased to near about 60 millivolt. So we have taken a reading of the output of the circuit, the tuned tank circuit at different frequencies. These are the outputs observed, and we converted it into the voltage gain as V out upon V in, and this is converted, voltage gain is again further converted into terms of dB, and for 74 we are getting 400 millivolt output, that is 20 times the input, and in terms of dB it is 26 dB. Here is sample calculation. We have calculated at 74 kilohertz 20 millivolt input, so for 100 millivolt is the output, 20 millivolt the input, 20 is the gain. So this is converted into dB. Theoretically we are calculating the resonant frequency as 1 upon 2 pi root over LC, and substituting the value of L as 100 microhenry and C as 47 nanofarad, we are getting the theoretical value as 73.41 kilohertz, and practically we got the resonant frequency at 74 kilohertz as we observed on CRO. So after plotting the graph, this is the graph. Along x-axis we are taking the frequency in hertz, and along y-axis we are taking the gain in dB. So this is resonating at 74 kilohertz approximately, where we are getting the maximum gain, and this is the 3 dB frequency. It is upper cutoff frequency is 86 kilohertz and lower 70 kilohertz, so the difference is 16 kilohertz, that is the bandwidth. So here it is more tuned, or it is resonated at the 74 kilohertz approximately. So in this way we are plotting and finding the bandwidth as 16 kilohertz and writing the value here. So that's it. Thank you.